Today we're going to be doing a problem on page 379, number 76. The problem says a solution of sodium cyanide has a pH of 12.10. How many grams of sodium cyanide are in 425 milliliters of solution with the same pH? All right, for this problem, we first want to start off by writing out the balanced equation for the reaction. The reaction reads as follows: NaCN aqueous plus H2O yields HCN aqueous plus NaOH aqueous. It's a pretty simple reaction. All the ratios between the compounds are 1 to 1. So now we can move on to the next part. For this next part, we first want to start by identifying the equilibrium expression and the value for the equilibrium constant. So we know that Kb is equal to the products over the reactants, and the products here are HCN times OH minus over CN minus. Now, it's also given on page 361 of the textbook. The Kb value for cyanide is given, as well as a bunch of other useful Ka and Kb values. So if you ever need to find them, just go to that page in the textbook. Again, that's page 361. So now for the next part, we want to we're trying to find out what the concentration of hydroxide is in this problem, and we're given the pH. So to start, what we can do is first, using the given pH, you want to find the pOH value, which will make it a lot easier for us to find the hydroxide concentration. So to find the pOH, we want to subtract the pH from 14. So 14 minus 12.1 is equal to 1.9. So the pOH of this reaction is 1.9. Now to find the concentration of OH from that, all you do is take 10 to the negative pOH. So 10 to the negative 1.9 is equal to 0.013 molarity. And again, as this reaction, as the ratio for this reaction is 1 to 1, the molarity of hydroxide is equal to the molarity of cyanic acid. So now that we know the two values in the numerator of the equilibrium expression, and now that we know that value of the equilibrium constant itself, we can use that information to solve for the concentration of cyanide in this reaction. So to do this, you first want to set up a simple ice table, and we see here from this ice table that once the reaction is at equilibrium, we have 0.13 molarity for HCN and NaOH, but an unknown value for the concentration of sodium cyanide. So if we set up our new equilibrium expression with these values that we've now calculated, we should get something like this. 1.7 times 10 to the negative 5, which is the Kb value, is equal to 0.13 squared over x. So as HCN and NaOH are both equal to 0.13, you can just square them. Obviously, it's simple algebra. And then you will divide by the unknown value of NaCN, which is x. And once you simplify and solve for x, you should get that the concentration of NaCN is 9.94 molar. From this, we want to find, the problem doesn't stop there, however, because we want to find the value of grams that, like how many grams NaCN are in the solution, not the molarity. So we have to do a couple more easy steps. So we have to convert the molarity into moles, and to do this, all we have to do is divide by the volume. Now don't forget, the initial volume is given as in milliliters, so we have to divide by 1,000 and find the value in liters, which is 0.425. So 9.94 times 0.425 is equal to 4.225 moles. And then all we have to do is convert to grams, multiply by the molar mass of sodium cyanide, which is 49 grams, and you get your final answer of 207.025 grams. All right, guys, hope that helped.